Okay, well, hello everyone. Thank you for coming, and thank you, Harold Silect, for hosting another MP University. It's always nice. It's also always nice to see that the SCOM is still moving. So before we get into the technical ins and outs of our latest management pack for SCOM, I'd like to give you a brief summary, everybody a brief summary of containerization or containers and why we have seen an accelerated adoption rate in the past 2 years, especially among our ISP and manufacturing customers. I'm sure that for some of you this will be familiar. Okay, so containers are isolated bundles of all the required components of an application. This includes the application and configuration files, the settings, dependencies, and the libraries. So similar to shipping containers, goods transferred from one mode of transport to another, and it's in a standardized logistic process. And a software container works in a sort of a similar way. It combines all necessary components for an application to run across various computing environments. So what does that mean? It means that you can run any application or service can be run on any OS, whether that's Linux, Windows, Unix, whatever flavor you have. It's basically a cloud native approach, so it can be run anywhere. And that includes also on premises. And actually, with our own customer base, we find that hybrid is basically a much adopted. It's a favored method. The application or service could be monolithic or it could be a microservice. And perhaps most importantly, in this case, it can be done in any language, right? It doesn't matter if it's Java, .NET, Python, Node, whatever flavor would work. So containerization allows a degree of operational systems management that basically abstracts the differences. And so, as I mentioned, it's a cloud native approach. And what that means is that basically you have a built-in failover system. It provides a resilience and the ability to maintain fast troubleshooting resolution for application at lower operational cost. And that applies both to hardware and the administrative operational level. So like a good functioning port or harbor, then it basically standardizes portability and eases scaling, whether that's up or down. And it can also just be just-in-time scaling, so to speak, right? It's very quick. So containerization has currently proven to be an optimal way of equalizing production deployment and scaling. And it enables infrastructure as a code and bridges the gap between developers and operations. So it means a much shorter line, and it basically provides more ways of organizing, operating, and managing system workloads. So, and perhaps the most important, of course, is the fact that there's constant availability on the user and the customer side. So whether it's an employee or user or what have you. Okay, so how does that look like? So initially, it's all relatively similar. You have your bare metal, your infrastructure and servers, the databases, and then on top of that, you have your operating system, and that contains your different files and your structure. And then after that, it changes quite a bit, and that's that in, for instance, a virtual or VM environment, then you'd have a hypervisor, and then on top of the hypervisor, you'd have a whole different myriad of OSs, and if your applications are fine and they're just something like only Windows or only Linux, it's less of a problem. But often it's just a mix and match, and that's something that containers basically tackles by having everything in its container software layer. And on top of that, then you have the binaries and the dependencies. And of course, with guest OSs, then those the binaries and dependencies can also be affected very much by those the way the different OS would work. And that's of course something that's just taken away with container technology or with containers. And finally, on top of that, you have your applications. Now, the thing is that with Kubernetes, it's actually it's two parts, right? So there's containerization, so container software, and then there's the orchestration of it. And that's important because basically containerization is something that it's actually been around for quite a while. It was something that Google used internally quite a lot from 2008 onwards. And within Google, it was actually referred to as the Borg. And for those of us who follow any Star Trek, then I think that most of us will know what a Borg is. They're basically an alien race of cybernetic organisms, and they're linked by a hive mind called the Collective. So that's basically the same idea, or rather the same fundamental concept behind containers. So containerization it brings a lot of advantages because containers are a lot more lightweight than virtual machines. And of course, what I mentioned before, the just-in-time approach, which means that if there's anything that from troubleshooting to peak use that can be addressed almost instantly. Now the thing is, though, is that containerization without orchestration isn't actually that helpful on an operations level. I mean, there's different systems out there, but ultimately, if you don't use orchestration, then you will be spending more time on what you're doing, your management, your operational systems, and so forth. I mean, and that includes everything from basically services, the processes of maintaining and keeping services up or down, or scaling them. That all becomes something that still adds to basically the typical workload of a systems admin or daily operations team. But of course, the thing is that there is a solution for this, and that's of course in orchestration. And now this is a very generic. I'm sure that this is something that anyone who's familiar with containerization has probably seen this generic architect drawing before. It's basically, it shows what Kubernetes, or rather, sorry, container orchestration actually does. So as you can see, basically the user and how you affect that is everything goes through the master, and in this case, it is a Kubernetes architectural drawing. And the master then will control the node and with the registry on top of that. And Vincent will talk a bit more about the different nodes and how this is so important, the clusters and pods and so on, and also why that's a reason why we designed our current pack the way we did. Also because of the fact that it's very difficult itself to monitor the container itself, so the compartmentalized place where the application or service is. Because basically containers are, relatively speaking, they're quite ephemeral. They can die basically, but of course that's taken care of by simply having another a node replace it, or another, and that's something that Vincent will address as well. Okay, so in the past, say 10 years, but certainly in the past 6 years, that's where how long we've been looking at this. There's about 30 established software solutions for containers on the market. That what I'm showing now is just a few of the ones that we've looked at, and also the most common ones and most used ones. And of those different container software solutions, there's also about 16 established orchestration tools. And again, this is just a selection of the most common. Now, and Vincent will cover the flavors of what we consider to be good starting points for our Kubernetes pack, our Kubernetes management pack. Essentially, each tool is supposed to cover the same thing, right? Each tool must make sure that the management of your container layer is basically that you can take full advantage of your sort of built-in redundancy, and also of the Borg cell, or at least the sort of hive mind idea. The fact that if something falls over, then something else will simply pick up where that object or that workflow or what have you dropped off. So how effective is containerization or orchestrated containerization from a business perspective? That's actually really quite, the difference is really quite sizable, especially in terms of manufacturing. And you can think of anything from manufacturing of machines to, as in the factory workflow, to pharmaceutical equipment or what have you. So the one of the main things is that it reduces the infrastructural complexity. Just because of your orchestration layer. Virtual machines siphon capacity because they require multiple operating systems, and containers run the applications independently, essentially compartmentalizing them on an operating system. So it basically means that you've made your environment modular, which also makes it easier to fix. And now the direct knock-on on that is, of course, that you have business agility, and I know that agility is quite a buzzword these days, but it is the case. It is genuinely the case that you're able to yeah, compensate and react much quicker than you would if you would you know, to different systems, or for instance, if you have a website that for between certain times has so much more traffic, or 100 times or 10 times or what have you more, than it would normally have to take care of. You know, those kind of things are all just, they just become irrelevant, or they become much easier to deal with if you're using containerization and orchestrated containerization. It also means that developers and DevOps can make small changes without quickly disrupting application workflows. So it means that nothing has to be stopped, nothing has to be paused, and so on. And that, of course, means that you have reliability and availability, which is on both the customer and the employee side. That's always going to give rise to greater sense of satisfaction. I mean, you, especially now with the sort of work from home, or at least this, again, a sort of hybrid work from home environments that we encounter among our customer base, then, you know, it's something that our companies and our customers do like, that they don't have to think about their systems as, yeah, perhaps they don't have to manage them as intensively as they would thanks to the containerization or orchestrated containerization. So that all of that together, of course, promotes operational efficiency, and again, DevOps productivity just carries on. There's a much greater flexibility throughout, because all of your developers, DevOps, what have you, they can test multiple concepts or scenarios basically in the same environment, in the same cloned environment as they would actually be implemented in production. So that makes it, for them, it makes it very easy. And last but not least, it basically increases security. And that's mostly because of the fact that the modular nature of containers means that if you have different people, especially external people, for example, and it's sensitive data, or it's an application that keeps medical records, then it's always a nice thing that you can essentially present everybody just with modules. So they're never actually in your actual network. So it means that everything that they're working on will always remain, yeah, within itself. Will remain module, and that means that compartmentalized, of course, which does make things a lot simpler to both on the operational sense to work with external agencies or bureaus or parties, and of course from a security perspective, there's going to be a lot less headache in terms of compliance and what have you. So that concludes my piece, and I would like to hand the floor over to Vincent. Are you going to share your screen, Vince?
Yes, thanks, Mark.
Thank you.
Moment. Let's share this one, and then we'll do this. Are you able to see my screen?
Yes.
All right, great.
Yep.
Okay, thank you, Mark. Thank you for the intro into the Kubernetes Management Pack. My name is Vincent de Vries, and I'm on the technical side of OPSLOGIX. And I've been developing management packs since, well, 2007. So basically since MOM became SCOM. What I want to do today is do a chat about how to build an enterprise management pack. And we've been doing that with the Kubernetes Management Pack. We've developed a great deal of it already. It's not completely ready yet, but we have it running at a couple of customers just to test it out, and they're happy with most of the features. So what I want to talk about is just how do you start off with an enterprise management pack like this? Well, let's go to the next slide. When you want to design a enterprise management pack, really, you really need to take a look at the architecture of the application you're going to be running. We've done that in the past with VMware and Oracle, and for the ones who can remember, BlackBerry, we also did that. So, you know, we have a good experience with actually monitor very large applications. Now, we've also learned from our mistakes, so I would like to share them with you, basically the design choices we made for Kubernetes and why we made them. So first, let's take a little bit of a look at the architecture of Kubernetes. As you can see on the left side, we have the control plane, which is basically the master node of the Kubernetes cluster. And on the right side, we have the nodes, which are basically the worker nodes, which run most of the workloads. Now, on the control plane, which we have on the master node, we run a couple of services, or Kubernetes runs a couple of services, I have to say. First of all, the Kube API server, you heard Mark talking about that already, but any interaction, so from a Kubernetes client to monitoring applications to other types of applications, go through the API server or the Kube API server. Now, next we have the etcd, which basically replicates all the information from the master node and what's happening to the nodes and to the other master servers, if there are any, so that they all have the same information and that they're all in sync. So it's basically a bit of a open source application which runs on there, but nonetheless is very important for the control of Kubernetes. Then we have the Kube scheduler, and the Kube scheduler basically schedules pods to be put on nodes or to be spawned on nodes. A couple of nodes depends how your deployment or what your deployment looks like. It can also take them away from nodes. It spins up containers and so forth. Then we have the Kube Control Manager. This is kind of like an overarching service for all the other services, and it basically makes the whole Kubernetes cluster run. Now, the last thing I would like to talk about is the Cloud Control Manager for the control plane, and the Cloud Control Manager is basically there for if you run Kubernetes on any type of cloud platform, so be it Azure or AWS or the Google Cloud or something like that. So it only looks at the interaction. So if you're running it on-prem, then you don't really need this Cloud Control Manager, or it's not activated. Now, how is all this important for the design of or the architecture of our management pack? Well, basically, we can see that the control plane is on the master node, and there will never be too many instances in SCOM of something like that. So basically, you'll create a few objects if you do a discovery. On the other hand, when you look at the nodes, there can be many nodes in a Kubernetes cluster. So it's the amount of servers you would actually add so from 100 to, I don't know, maybe 1,000 or something, which is still very manageable by SCOM itself in terms of objects. But when you start looking at things like pods, pods become, well, they can run in thousands or tens of thousands if you have a large enterprise environment, and not to speak about all the containers contained by the pods. So when we start looking at the design of our management pack, we really have to take these things into account. So what do we have to look at with the design, or what are our design choices for this management pack? Well, first of all, we take a good hard look at the SCOM class structure. Then we also look at how we collect the data. I'll talk about the collector we use in the Kubernetes management pack. And then at the end, which applications or what parts of the application are we going to monitor and what are we not going to monitor. So let's start with our SCOM class structure and design. First of all, let's talk about relationships in the management pack. Now, most management packs, when you start off authoring, you'll create a hosting relationship between a parent object and a child object. So the child object is contained by the parent object, or by the host, as you can call it. Now, an example of this would be something like a Windows server, and the Windows server contains a hard disk. Without the server, a hard disk wouldn't exist. So this would be the relationship. Now, you can imagine that with Kubernetes, you can discover a Kubernetes cluster, and under that, you could have a hosting relationship with all the nodes or other components, but let's take nodes as an example. So this would still go well. You know, maybe you have 100 or 10 or 100 or 1,000 nodes, and SCOM would still be perfectly happy monitoring all this. But if you would actually create another relationship, so basically a lot of worker nodes, these nodes, these worker nodes contain all the pods, then these pods all of a sudden would become a large amount. So, you know, if you have something like 10,000 pods and you want to run these all within one SCOM server or one management server, since we use management servers to actually monitor the application, SCOM would start having a hard time. Now, if you would increase this even more, say to 20,000 or something, you know, you don't really know what's going to happen anymore with your management server. It might just fail, or, you know, it might run out of memory or out of handle counts or something like that. And one of the things, though, is about the hosting relationship is that it always runs on one agent. Now, if you have a SCOM environment with multiple management servers, usually you can load balance a lot of objects on it. But what SCOM wants to do on a management server when there's a hosting relationship is keep all the hierarchy together. So it'll keep the whole structure on one management server. So if you have a cluster which hosts nodes, which hosts the pods, it will keep that on one management server, and it will never load balance it to anything else. So this presents a problem for large environments. Now, the solution to that is to let go of the hosting relationship. And when you let go of the hosting relationship, you might not really get all the nice roll-ups which you automatically get in the Health Explorer when you open that in SCOM. But on the other hand, what you do get back for it is that, for example, we don't create a hosting relationship for pods, is that it'll load balance over multiple management servers, however many you choose to use. So this is actually a crucial design choice, which you're or for your management packs, and you need to really take that into account before you start building your management pack, how your application or where the biggest amount of objects are going to be from your application. Another one is security. So when you start off with a Kubernetes cluster, usually you'll have a kube config file somewhere, which is plain text. Now, if you want to log on to a Kubernetes cluster, you probably need this file, and the ones who've used Kubernetes already are familiar with it. It's also horrible for security because you don't want to keep a plain text file somewhere in your SCOM environment. So one of the things we've done is we've created a binary run as account with a run as profile. And basically what we do is we encrypt the kube config file into there, so that you don't have to keep it in plain text somewhere in your SCOM environment. And from there, it's passed to the agent where it's decrypted runtime. Now, when you decrypt at runtime, of course, it's not going to be available anywhere in your server. So it's just going to be passed to the collector, and then ultimately it'll authenticate with your Kubernetes cluster. So that's also another design choice we made when you look at a class structure, because you actually have to factor in the run as profile. So let's go to the use of a collector. In our management packs, so all the management packs we use or we author, we use collectors. And I call it a smart collector because it does a lot of smart things for your management pack and for your Kubernetes environment, but also for your SCOM environment. Now, one of the nicest things it does, it reduces the load on your SCOM environment, and it does it in a couple of ways. So first of all, every agent, so also on a management server, produces or creates handles which is a handle count on in your SCOM environment. Now, every process has handles. So usually on a normal agent, you could go up to about 10,000 before you get an alert. And on management servers, you could go up to about 20,000 before you get an alert. Now, the Windows operating system pretty much allows every Windows process to spin up about it was up to about 40,000 handles, so that's a pretty high handle count. But after that, strange things start happening. It starts running out of memory and so forth. So that's a pretty high number. But when you consider that if you're going to be monitoring a large amount of objects, you're going to have a large amount of workflows. Now, these workflows, they all create handles on their own. And if you even, if you create more if you add more modules to the workflow, then they start adding even more handles to the handle count. Now, we've run into the situation before where you actually exhaust the whole pool. So you go over 20,000 on the handle count, and then your SCOM environment starts restarting its agents. And if it does this continuously, it's really bad for your SCOM environment, and it doesn't really monitor all that well anymore. So you want to keep this down. So by using a collector, what you actually do is you minimize the amount of workflows you run, and you offload this to the collector service or the process which runs the collector, and therefore making everything a lot more efficient. So when you write your own enterprise management pack, you could consider doing something like this to offload all the processes. Now, another reason why we really like to use a collector is for cookdown, because we can homogenize the all the information we collect from Kubernetes or any other management pack, such as VMware or whatever. And because all the modules are the same and we can put the same inputs into the module, SCOM will cook down all the information for us. So basically what it'll do, it'll only do one request to our Kubernetes environment for all the monitors, and then just check this information for the relevant information for the monitors and rules. Instead of actually, doing one request for every monitor and every rule, which is quite detrimental for both SCOM and sometimes also the application you're monitoring. Now, the third thing I want to talk about is paging in a smart collector. A lot of the time, SCOM just polls a system to see how it's doing, and you get back the same information. If you consider something like disk space, the disk space in a lot of systems doesn't change that much. If you're like 100 MB, that could remain the same for days. So, but if you poll it every time and you pull 100 MB, the workflow would give you back 100 MB, and SCOM would need to process that information and insert it in the database somewhere. Now, what we like to do with paging is the collector already filters out this information and says, hey, basically, I know that you're returning the same information, so I'm not going to pass it on to SCOM this time so that it doesn't have to process this information. And by default, we put this for, every 5 minutes. You can change the interval for that, but we thought it was a good average, especially for monitors. So again, there you make things more efficient on the SCOM side and hopefully make it run smoother. Now, one thing I put there as well is auto deploying, and it's not so much a feature for SCOM itself, which helps SCOM run more efficiently, but it's more to help you. Personally, I don't like having to install collectors manually on all the management servers, because you tend to forget when you add a new management server or something like a gateway server, and it's just very inconvenient. So what we've done is we created an auto-deploying collector, which is automatically deployed when it notices that one of the workloads is on the management server. So it looks at the resource pools and then says, oh, okay, so we're running here on these resource pools on these management servers or gateway servers. So the collector needs to be deployed there. And it will also do this for your gateway server and also any updates to the collector. So when you create a management pack, you also have to think about what you don't want to monitor. Mostly you do not want to monitor very volatile objects. And what do we mean by volatile objects? These are things that change very often. In the context of Kubernetes, we could think about things like containers themselves. You could argue that pods are already pretty volatile, but we chose to monitor them anyway. But especially containers, since they're created and destroyed at such a high pace, it might not be worth monitoring them. And SCOM takes a snapshot of a discovery snapshot around every 4 to 8 hours usually. And if it changes every time, you're going to change your configuration every time, which is not the greatest thing you can achieve by with SCOM. Also, the information you're monitoring information is not really going to be up to date so much if you use or if you try to discover very volatile objects, because you discover it at one point and 8 hours later, well, a lot has changed. So for 8 hours, you had information which was not very up to date. Now you could, some people, they say, well, you can actually set your discovery a lot faster. But that would be a very bad idea, because if you set your discovery extremely fast, especially for a large amount of objects, then you can get what you call a discovery churn, that it tries to actually distribute all the information from the discovery to all its agents, but before it actually distributed all of the information, it already has a new discovery. So this is a good way to wreck your SCOM environment. Also in Kubernetes, we do not monitor the applications which are in the containerized applications. It might be pretty self-evident, but I put it here anyway, because every application running inside the container might be a completely different application which you want to monitor, and you might need a complete different management pack for. So that is something we don't do. Now, just to give you a little bit of information on what we do monitor inside the Kubernetes management pack, I took a screenshot of a view inside the SCOM console, and you can see there that first of all we monitor the Kubernetes clusters, and we also do the daemon sets. So daemon sets are basically sets of pods which you have to run on every worker node. You can change that a little bit. We monitor deployments, and deployments are basically the whole application you monitor. So if you deploy a website plus a database, that would be considered an application or deployment. We monitor the Kubernetes collector, which is not very exciting because that's our own collector which we monitor. We do namespaces, and namespaces contain your deployments. We monitor nodes, and obviously for the nodes we monitor the orchestration of pods, but we also monitor things like CPU and memory usage. And of course, for the pods, we also monitor orchestration for those, and the memory usage and CPU and disk space and so forth. So finally, we also monitor services, and these are the things that expose your application to the outside world. So that was a very quick overview of the basically Kubernetes management pack and the design choices we made for it. I think the takeaway for this is, first critically look at your application, really get a feel for how you have to design your class structure, how you'd need to implement security, and then finally, do your discoveries and do all the other stuff, rules and monitors you want to look at. And also, if you also think about if you're going to be monitoring a large amount of objects, are you going to go for something like a collector, or are you going to monitor it straight from all your workflows? So that's it for me. I think we have a couple of minutes left, but I'll go back to Harold.
All right, thanks very much, Vincent and Mark. It's great to see these real world examples of developing commercial management packs and some of the things you go through. It looks like a great solution and something we'll be really interested to take a look at for sure. So thank you so much, guys. Let's see if there's any questions. A question just came in on the chat window, Vincent, if you want to take a look. Does this management pack have any ability of monitoring cron jobs?
So we were looking at that. I would need to, at this moment, I have to say no. We were looking at the events in the management pack, and then it would actually, it might be in there, but as such, or just at this point in time, it doesn't.
All right. Any other questions for Vincent? Please use either the chat window or the Q&A window. Oh, yep. There's one more question on pricing, Vincent, that I'll publish up in the Q&A.
All right. Okay. You want me to say something about the pricing, or?
Yeah, sure.
Okay, so what we're thinking of is it's not set in stone yet because we still have to kind of get a feel for it. But what we want to do is we're going to price it per core, and in a similar, if you're familiar with our VMware management pack, I think it's similar pricing to that. I can't specify the price of one core yet. I would need to talk to sales. Usually I do all the technical stuff. But if you would like a more specific answer, I'd be happy to take your email address and give you an answer.